Okay, this is actually question 5. There's a series of questions that kind of go along, 5 questions that go along with this stuff. This is question 5, and this is how you do it. How many word arrangements can be made with this word if the repeated letters are treated as all different letters? Well, count them up. 1, 2, 3, 4, 5. It's 7 again. And so, if they're all different, that means you've got 7 choices in the first box. I'd make 7 little boxes there in a row. 7 choices, then 6, then 5. That's 7 factorial. And if they're treated as identical, then you have 7 choices, 7, 7, all the way 7 to the 7th power. And that's why your first question is pretty darn easy. 7 factorial for arranging 7 things in 7 boxes when they cannot be repeated, and 7 to the 7th when they can. Okay, now, this is the ones that people find pretty challenging, and you got to read really carefully, and this one's got a little bit of a trick in it. How many word arrangements can be made with the letter for this word if the word starts and ends with the same letter, Well, starting and ending with the same letter, it kind of looks to me like that could only work with N, because you need 2. If it's going to be the same, it's got to be N, doesn't it? So that's why I'm going to have to put an N there and an N there. And it doesn't say that they're to be treated identical, so you assume that if this is like N1 and N2, you could switch. There'd be 2 ways to arrange with the N's on the outside. Well, how many letters would you be left with in the middle? If you get rid of the N's have to be placed on the ends, right? The other 5 letters will be in the middle. There's 5 letters there. C, W, I, E, R, and S. The N's are in the middle. The first time I did it, I went, yeah, 5 factorial, that's the answer. And I don't think so, because if they don't tell you that the N's that they are to be treated as identical, you better treat them as different. It feels a bit weird to me, because it feels like it would be the same, but it's not the same arrangement. If we treat them as different, there's 2 ways to do it, 2 factorial. So 5 factorial, 2 factorial, that's 240. Well, let's try it with ending with a W and S. You see, we just play the same game. I like to put the boxes out there in my mind, even on the page there. And I'm going to start by putting a W and an S here. And then look at the letters that I have left. Well, if I start with a W and end with an S, I'm locked in. There's no choice at all there. That's it. So the only choices, that's only one arrangement. But hey, I've got 5 different letters in here, and I can choose the end. The ends can be considered. They don't say that they shouldn't be identical, so they don't say that that they should be treated as identical. So you had to treat them as different, I'm pretty sure. So that means that's your answer. It's 5 factorial. There's 120 ways, because that's only one way to do it. And then 120 different ways the rest of the letters can be arranged. And I think that's that question done.